Hi class, how are you today? That's a circle. Do you guys not see it? It's right there. There's a circle right here. Why is that? The world may never know. The learning target for today is to be able to solve for the measures of arcs and central angles in circles. Like this one right here. For the scale 3, you can solve for the measures of arcs and central angles in circles. 2, you can find the measure of arcs and central angles if you know the measure of one. So if you know the measure of an arc, you can find the measure of a central angle, and vice versa. 1, you can name arcs and central angles. And 0, you cannot name arcs and central angles. Let's get started. Alright, so before we get started on central angles, you're probably thinking, what is a central angle? Well, to do that, I'm going to go over some vocab. So, circles is something brand new to you guys. Well, probably not too new. You probably know some things like finding circumference or finding the area of a circle, hopefully. But here are some vocab terms you may or may not know. Hopefully you know some of the earlier ones, but you probably won't know some of the later ones, or even some I have after this, because there's lots of vocab words for circles. Alright, so I also have this circle over here for a nice image, to show where these things are on the circle. So first, what is a circle? We did have a definition earlier in the year, which was a shape where all the points are equidistant from the center. So remember, here's the center, C, and then all of these points are the same distance away. Now, I'm also going to show how to name many of these things. So how you name a circle is actually pretty simple. It's just a circle with a dot at its center and then the letter that is its center. So this essentially says circle with center C. A radius is a line segment from the center of a circle to any point on the circle. And just so people know, if you're talking about multiple, you will say radii. So you have one radius, but many radii. And how you name it is just like any line, but the ones specifically on here are BC, CD, and AC. So from the center to any point on the circle. And so these are the three we have in this circle. So a diameter is a line segment that passes through the center of a circle whose endpoints lie on the circle. So, like so. So that one is diameter AD. Just like any other line segment, that's how you name it. A central angle is an angle whose vertex is at the center of the circle. So, see here, there's an angle at C. So this angle here and this angle here are both central angles. And you name those just like you name any other angles, with 3 letters and the vertex in the center. So ACB and DCB. Technically, you could have ACD as well, but that's just a line which is 180 degrees. An arc is a portion of the circumference of a circle, so it's only a part of the circumference instead of the whole thing. Now, there are different kinds of arcs. First, the minor arc, which is less than 180 degrees. So you could do this arc here or this arc here. And you name these with 2 letters, such as AB and BD with the little arc over them. You can also have major arcs which are greater than 180 degrees, such as going all the way around this point. And these are always named with 3 letters. And when you name it with 3 letters, you have to start at 1, then go to one of the points in the middle of the arc, and then go to the end. So in this case, A, D, B, and we also have B, A, D. And then we have semicircles, which are equal to 180 degrees. They are half the circle. And so you need 3 letters to name those as well, such as ABD. However, that's a specific arc, this arc here. If we wanted to talk about this one, we would actually have to add a point just randomly over here. So if we added a point E over here, then we can name the semicircle AED. Finally, a sector is a region of a circle bounded by a central angle and its arc. So a sector can be just the region bounded, like the region around an angle that the angle creates within the arc. So, such as in this case, this whole area right here. Or even in this case, this one over here. So it's the area bounded by it, the area that the angle and the arc create. And you name those just by saying sector and then the 3 letters that make the angle, in the same order that you name the angle. So with the vertex, the center, in the middle. Now for some more vocab. So an inscribed polygon. It's a polygon which each vertex lies on the circle. So in this picture we have a triangle. Triangle ABC. E. ABE. C is the center, and that's all there is about it. It's the center. So triangle ABE, and we name it as if we would name any other triangle. Triangle ABE. An inscribed angle is an angle with its vertex on the circle and rays that intersect the circle. So we have 3 angles that are on the circle, and name them using 3 letters as per usual. Angle BAE, angle ABE, and angle BEA. A chord is a line segment whose endpoints are on the circle. So, line segment, line segment, line segment. So those 3 are line segments that are on a circle. They happen to make a shape here, a triangle, but they don't always have to. They just have to be any line segments that go from one point on the circle to the other. And they're named just like any other line segments, AB, BE, AE. A secant is a line that intersects a circle at exactly 2 points. So if you see this line here, intersects the circle at A and at E. So that's a secant. And it's named just like any other line, line AE. A tangent is a line that intersects a circle at exactly 1 point. So this line right here intersects right here, right at D, and it just intersects the edge of it. It only hits at 1 point and then keeps going. And again, that is also just like any other line. That's why I had to add this point here, F, so we could have 2 points to name it. Line FD. And a point of tangency is a point in which a tangent line intersects with a circle. So the point of tangency here is right here, at D. And remember, points are just single letters. So, D. And finally, concentric circles are two circles that share the same center. So in this picture here, both of these circles have a center C. So they have the same center, but they're two different circles. Now finally, let's get to the central angles I was talking about. So central angles are very nice. The arc measurement is equal to the central angle measurement. So for number 1, I say find the measure of arc AB. So it's essentially how much of the arc is there. So if the angle is 76 degrees, the measure of the arc will also be 76 degrees. So on number 2, I want you to find the measure of arc IJK. Remember, that's a major arc, so it goes I, J, and then all the way around to K. The one measurement we do have is this arc, JL, is 137 degrees. However, if you'll notice, this line goes through the center. So since the line goes through the center, it's a diameter, and it creates a semicircle. So if this arc here, this whole arc is 137 degrees, this arc will just be 180, the measure of a semicircle, minus the 137, or 43 degrees. And now, notice that these two angles are vertical angles. So if the angles are vertical angles, then the arcs share the same property. So the angles are vertical angles, therefore congruent, so the arcs are congruent. So this arc is also 43 degrees. Now we've got all the measurements for this entire arc here. So now add them all up, and that'll give us the arc. 223 degrees. Now for this last example, we can find the measure of angle DHF. And to do that, we need to solve for x. So if you notice here, these two angles are congruent, meaning these two arcs are congruent. So if we have the measure of these two arcs here, we can use that to find angle DHF, this whole angle here. So if these are congruent, we set them equal to each other and solve for x. So subtract 2x from both sides. That'll give you x plus 12 is equal to 27. Subtract 12 from both sides. That'll give you x equals 15. So now that we know x, we have to plug it into both of these arcs, or really just one of them, and then multiply by 2. So we know x is 15, so we plug x in here. That'll give us 3 times 15, which is 45, plus 12 is equal to 57. So this angle here, this arc here, and the angle is 57 degrees, which means this is also 57 degrees. So that means the entire angle is 114 degrees. Alright, now time for the sponge. Find the measure of the indicated angles or arcs. Number 1, find the measure of arc AD. And number 2, find the measure of angle NOL. So number 1, this angle is 116 degrees, 87 degrees. This arc is 5x minus 17, this arc here, and this arc is 2x plus 6. Alright, that's it for the lesson. Once again, please make sure to take notes on the entire lesson. Attempt the sponge, rank yourself, take a picture of everything. Submit it all to Google Classroom, and have a good night.